Hello students, in today's session of NCERT Chapter, Optics and further very basics on refraction from curved surfaces will be cleared through illustrations. In today's session, we have gone through refraction from curved surfaces and also laws of refraction, real operator, total internal refraction, principal reversibility. These concepts have been cleared through illustrations, which you can review on YouTube channel SethiSwiftLearn. In today's session, we are going to discuss image formation of concave and convex lens, different cases. What is linear magnification? What is linear magnification? Lenses in contact. What is the focus? When object will be virtual, and or other number of topics which are going to be cleared through this session. It is requested go through the session completely. In this case, illustrations are being taken from NCERT back exercise. Right? Now, let's start with the question and concepts. Question is, discuss different cases of image formation in convex lens and concave lens. Concept applicable in solution. To form an image, two rays are required. Generally, we take one ray parallel to the principal axis. After refraction, it passes. This is the line parallel to the principal axis. After refraction, goes to this one. Another ray of light passing to the optical center move undeviated. These two lines will either actually meet. If actually meet, then real image. If appears to meet like this, if we extend it backward, then virtual image is formed, right? Possible cases are when object is between infinity and 2f. Infinity and 2f. So object की position है, ये image की position है. It becomes between 2f and infinity. When it is at 2f, it will become at 2f. When it is between 2f and f, then it will become between 2f and infinity. In this case, it is between f and 2f. And next, first case, second case, third case, fourth case. Fourth case is between f and optical center. Then parallel. Image at infinity, refracted rays become parallel. And finally, this is for convex lens. This is called convex lens. Right? When it is between f and c, it is at f. And at between f and c, then virtual, erect, magnified. Diversifying, if we extend it backward, it is meet at this, appears to meet at this point. Then this is the case, right? So 5 cases are there here. As the object is moving towards the lens, image is moving away from this, up to this point, right? Then, when it is between f and c, image form is on the same side as that of the object. These cases are only for real objects. Real objects, right? And for concave lens, Only one case is there. This is also for real object. Virtual, erect and diminished. In this case, the payload ray after reflection goes like this, and this is undeviated, meet at this point between F and C. Whatever the position of this may be, this is a single case, right? These are the possible cases. In four cases, real image is diminished, same size, magnified, become parallel, then magnified. Means as the object is moving towards the optical center F, image is moving away and size is increasing. But at F, it will become that image becomes infinity, and when it is between F and C, it becomes magnified, erect, and virtual. Right? Now, next question. Question is, double convex lenses are to be manufactured from a glass or refractive index 1.55 with both faces of same radius of curvature. What is the radius of curvature required if focal length is to be 20 centimeter? Means requirement of question is R, we have to find it out. F is given to 20 centimeter. We have to form like this, double convex lens. Double convex lens is to form R1 equal to R2 equal to R2. We know lens maker's formula. Formula 1 over V minus 1 over U equal to 1 by F equal to mu minus 1 over R1 minus 1 over R2. Right? Main thing is to identify mu. What is mu? Mu is refractive index of medium, refractive index of material of lens with respect to the medium in which it is placed. This is the only thing. Then therefore, substituting the values, in this case, 1 by F. F is given to 20. 1 by 20 equal to, nothing mentioned regarding the focus, we will consider as 1.55 with respect to here, 1.55. 1.55, 1 over R minus 1 upon minus R. This comes out to 0.55 into 2 upon R, 1 by 20. Right? On simplification, R comes out to be 20 into 2 into 0.55. This comes out to 40 into 0.55. That is 2 centimeters. That should be the answer. Main thing is here is we have to use the lens maker formula. Be very, very careful regarding mu. Mu is the refractive index of material of lens with respect to the medium in which it is placed. In this case, from a glass or refractor. In this case, it is made of glass. If nothing is mentioned, we have to consider as air, right? So 1.55 refractive of the medium is 1.55 with respect to air. This distance is R1, this distance is R2. R1, R2. This to be taken as positive, this to be taken as negative. Right? The answer is 22 centimeter. Requirement was this. What is the radius of curvature? Radius of curvature is 22 centimeter. Right? Next question. Question is, a beam of light converges at the point P A lens is placed in the path of convergent beam of 12 cm from P. At what point does the beam converge the lens is? Convex lens of focal length 20 cm part A, and part B, concave lens of focal length 60 cm. We have to consider two cases. Question is taken from NCERT back exercise. Right, concept applicable and solution. This is the conveyor. This point is P, converging beam. Lens is placed here. This is the convex lens. This is the convex lens. Convection focus positive होती है, that is 20 centimeter. In this case, this will be U. U will be 20 centimeter. U will be 12 centimeter. U will be positive. This is, in this case, object is virtual. Object is virtual. To find the position of image, 1 over V minus 1 over U equal to 1 by F. 1 over V minus 1 over U, 1 by 12, equal to 1 by 20. On simplification, 1 by V equal to 1 by 20 plus 1 by 12. That comes out to 63 plus 5, 8 by 60. So V comes out to be 60 by 8, that is 30 by 4, that is 7.5 centimeter. That is position of image. Image will be 7.5 centimeter to the right of lens where beam is converging. Beam is converging. This is the position part 1. If B part is simple, F is to be taken as negative. Negative होगी, that will be 16. Using formula 1 over V minus 1 over U equal to 1 by F. 1 over V minus 1 over 12 equal to minus 1 by 16. 1 over V equal to minus 1 by 16 plus 1 by 12. This comes out to be 48 minus 3 plus 4. So V comes out to be 48 centimeter. If concave lens position of image will be at 48 centimeter towards right of the lens. Right? This is the answer. Next question. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE main, JEE advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very, very helpful and useful, which you can review on YouTube channel SethiSwiftLearn. In addition to this, I would like to say that these papers, complete video of sessions are available on SethiSwiftLearn YouTube channel, which you can review on SethiSwiftLearn. In addition to this, further, these papers, detailed solution with additional information available on website SethiSwiftLearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल SethiSwiftLearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question. Question is, an object of size 3 cm placed 14 cm in front of a concave lens of focal length 21 cm. Concave lens like this. This is the concave lens. Given describe the image produced by the lens. What happens if the object is moved further away from the lens? Question taken from NCERT back exercise. Concept applicable in solution. Simple 1 over V minus 1 over U equal to 1 by F. And magnification, linear magnification. I upon O equal to V upon Q. V upon U. Right? In that case, according to question, size of object O is going to 3 cm. U is minus 12 cm, 14 cm. F is 21 cm. Therefore, 1 over V minus 1 over U equal to 1 by F. 1 over V will be equal to 1 by minus 1 by 21 plus 1 upon minus 14. On simplification, simplify. This comes out to be 21 into 14 minus 14 minus 21, that is minus 35 upon 21 into 14. So 1 over V. V comes out to be 8.4 centimeter on calculation. Means position of image is position of image is 8.4 centimeter towards the side where object is placed. And size is good 3 centimeter. V is this one. Now to find the size of image, I, using I upon O equal to V upon U, I upon O. O is given to you 3 centimeter. 3 divided by V minus 8.4 minus 14. On simplification, this comes out to 1.8 centimeter. 1.8 centimeter. Means I positive means just ये है same side. तो on erect आएगी, virtual आएगी, ठीक है? Like this. Now next part is what happens if the object is moved away from the lens. Means this is the case. This is the object. The object is moved like this. Image will move also in this side. Image will move towards focus, but not beyond focus, right? And size will go on decreasing. This is the happening when object is moved like this, right? Next question. Question is, what is the focal length of convex lens of focal length 30 cm contact with concave lens of focal length 20 cm? Is the combination is a converging diverging lens? Ignore thickness of the lenses. Question is taken from NCERT back exercise. Concept applicable to when lenses are put in contact of negligible thicknesses, then 1 by f will be equal to 1 by f1, 1 by f2 plus 1 by f3 and so on. Now according to question, convex lens focal length positive 30 centimeter, f2 is this is convex lens, concave lens focal length will be negative 20 centimeter. Therefore, focal length of combination focal length of combination 1 by f will be equal to 1 by 30 minus 1 by 20 on simplification 1 by 20. So this comes out to 60. 2 minus 3, that is minus 1 by 60. F comes out to minus 60 centimeter. Means as final combination focal length is negative. Therefore, combination will behave as concave lens. That is not converging but diverging. Right. Next question. Question is, a screen is placed 90 centimeter from an object. The image of the object on a screen is shown by convex lens at two different positions, different locations, separated by a distance of 20 centimeter. Find the focal length of the lens. Question is taken from NCERT back exercise. Concept applicable in solution. Concept applicable is displacement method. What is displacement method? These are the two positions of convex lens. Two positions. Positions of convex lens. This is the object. This is a screen on which image is formed. In this case, according to question, X is given to you. Different position of location, that is X 20 centimeter. X and D is given to 90 centimeter. This is the D. D is given to 90 centimeter. You know the formula 1 over V minus 1 over U equal to 1 by F. If this is D, this is U, so this will be D minus U. If this is D minus U minus D equal to 1 by F. इसको simplify करें तो we would get U equal to D plus minus under root D minus 4F upon 2. In this case, three cases are arrived. Three cases. When D less than 4F, when D equal to 4F, when D greater than 4F. No real object. No real object. D less than only u will be equal to, in this case, d equal to 4f, u equal to d by 2, d by 2, u equal to 4f here, u comes out to be d by 2. D by 2 means this is 4f, so this will be at, object will be at 2f, image will be at 2f. So minimum distance is 4f for real object, real image. Minimum distance between object and image for real image is equal to 4f. Right? If greater than two positions of u, means two positions of u, that is two positions of image. Right? These are three cases. In this case, then focal length is given by d square minus x square divided by 4d, and O equal to under root I1, I2. These are the two basic formula applicable here. And one point is this very, very important for displacement. In two different position objects, size of images will be different. Size of object is constant, then geometric mean of sizes of images will be the size of the object. Right? Now we have to find the focal length. Focal length means substituting f equal to d square minus x square upon 4d, that is 90 square minus 20 square upon 4 into 90, or 21 point something centimeter. This is the answer. In this case, we derive number of MCQs to find the size of image, to find the size of object, what is the minimum distance for real image between the object and that is equal to the 4f, right? Now, I would like to request, if you are new to my YouTube channel, SethiSwiftLearn, Sethi, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.